Alright, so let's take a look at first section, which is 7.5. So a few more identities we're going to look at, and we're also going to do some calculations. So first thing is I just want you to look at both of those. The sine of x plus 3 in parentheses, and then sine of x plus sine of 3. Those aren't equivalent. It's not like you can just take the word sine and distribute it. You can distribute a number on the outside of parentheses, but you can't distribute a word. Right? That doesn't work. Right. So the question is, if this doesn't work, if you can't do this, then how could you simplify something where you have addition inside the parentheses? Or subtraction? Well, there's an identity for when you have a sum or a difference inside parentheses. And I'm going to show you what it is. But it's not that. Okay. If you wanted, you could graph what's on the left, graph what's on the right, and they look totally different. They don't match up at all. But I'm just going to save time and not graph them. All right, so we're going to look at 6 different identities. Okay? These aren't ones you need to memorize. You can put them all on a reference sheet for the test. You just have to know how to use them. There's 2 for sine, 2 for cosine, 2 for tangent. Each one that we look at, we're going to have 1 for a sum and then 1 for a difference. That's why I said 2 for sine, 2 for cosine, 2 for tangent. The first one I'm going to show you is a cosine one, and it's when there's a difference inside. We are not going to prove where that one comes from. You can, and the proof is in your book, but it'll probably take me about 15 minutes to go through it. So it would take up a real good chunk of time, and I'm not going to ask you to prove where that comes from on the test. So, alpha and beta would just be 2 numbers. Okay. In general, you want alpha and beta to be multiples of 30 and 45, because those are ones we know how to work with. All right. So if you have the cosine of a difference, it's the cosine of the first. I could just call alpha the first and beta the second. Cosine first, cosine second, plus sine first times sine second. And you just do that calculation out. Again, the proof is on page 409. We're going to skip over that. Okay, and we're going to jump right into an example. Does everybody have that formula? Okay. So, I want to find the exact answer for the cosine of 15. Now, if I type it in on the graphing calculator, this is what's going to happen. You're going to get a decimal. But that's not the exact answer. It's about 0.9659. I'll write that down, but that's not the answer. What I'll do is once I get my answer, I'll see if it's 0.9659, and then I know I'm right. Okay. But they want the exact answer. So the first thing we've got to do is somehow rewrite the number 15. You can write it as a sum or a difference. The only trick is you've got to use numbers that are multiples of 30 and 45. So you can use numbers like this. Okay. You can pick any number in that list and you can keep going. Or you can pick any number in this list. And there's some overlap there, but I'm just counting by 30s in the first one and 45s in the second one. Those are multiples of 30 and 45. So, can anybody tell me how you could write 15 using one number from each list? How could you write 15? Yep.
45 minus 30.
Yep. You can write it as 45 minus 30. And that's what we're going to do right here. 45 minus 30. Now you've got a difference of 2 things. That's the first one. That's the second one. So if we go back to our formula, that's That's the first one. That's the second one. So now you're just going to fill in that formula on the right, except instead of alpha, put the first one that we had, which was 45. And everywhere you see a beta, put the second one, which is 30. Okay. So let's fill it out. So cosine of the first times cosine of the second. And then plus sine of the first, sine of the second. Plus sine of the first, sine of the second. Now, the reason I said you can use a reference sheet is because once you know all the ones we're going to do, they're all kind of the same. Like sometimes it's cosine, cosine minus sine, sine. This one is a plus. It's kind of tricky to remember them all because they're very similar. Okay, now we can use a calculator and figure out each one of these. We have 4 of them to figure out. Now remember, we have to write exact answers. Okay, so let's start with the cosine of 45. You get 0.707. We can't write 0.707, it's not exact. But earlier somebody said a square root that had something to do with a 45, 45, 90. I think Nathan had said it. Does anyone remember? Square root of 3 has to do with multiples of 30 and 60. But square root of something else has to do with 45s. Yeah, that number right there, 0.707, if you take the square root of 2 and divide by 2, that's exactly what we just got. There's not many of these you have to remember. That is one of them. 0.707 is the square root of 2 over 2. Okay, there's like maybe 4 of them to know. So I would just try to remember or write that one down on your reference sheet. Okay, so the first one is square root 2 over 2. Times. And now let's figure out what the cosine of 30 is. Okay, another decimal. Can't write it as a decimal, but this has to do with another square root. Which square root does this have to do with?
Is it mine? The one I said?
Yeah.
Okay, square root of 3.
Yeah, this one has to do with the square root of 3. Let's look at what the square root of 3 is. All right, the square root of 3 is not 0.866, but does anyone have a guess what you could do with the square root of 3? And it would be 0.866?
Divided by 2?
Yep. Divided by 2, that's usually the trick. The square root of 3 over 2 is the number 0.866, and so on. So the cosine of 30, here's the answer. That's the square root of 3 over 2. Okay, we did these when we did unit circle trig. We're not going back and doing it again, because if I wanted to find this with unit circle trig by hand, and we don't remember how, it's going to take me like 5 or 10 minutes to just go back through and how to get this number. We already proved where this number came from a while ago. So just try to remember or write down 0.866 is root 3 over 2. Okay, so that's that one. 2. Plus, let's see what the sine of 45 is. Sine 45. We've already seen that number before. 0.707 again. How do you write? That's the square root of 2 over 2. So after a while, you're going to start seeing the same numbers come up. Okay, and then the sine of 30, well, that one just comes out nice. Right? So we just write a half. Okay, so now when you multiply fractions, you don't need a common denominator. Just multiply these two together, and then those two. Square root of 2 times square root of 3 would be the square root of... Don't think too hard. 6. I mean, you can multiply square roots, you can't add them. Like you can't say the square root of 2 plus the square root of 3 is the square root of 5. That doesn't work at all. But multiplying it does. And then 2 times 2 is in the bottom. That's 4. And now do the same thing here. Multiply what's in the top. Square root of 2 times 1. Square root of 2. And then the bottom is 2 times 2 again, which is 4. Now, since you have a common denominator, you can just put them together. Just do it like this. That's how you'd write the final answer. Okay, let's see if square root of 6 plus square root of 2 over 4 comes out to 0.9659. Because I typed this in to start with, and that's what I got. But that's a decimal. That's exact. And that's all you can do. Questions on how we got that? No question? Thank you. The wind currents. Okay, let's check it. So let's type in the square root of 6 plus the square root of 2. That's the numerator, and now divide it by 4. You get 0.9659. The original problem was the cosine of 15. 0.9659. So we found out how to write this answer as an exact fraction. And that's how you do it. So you see square root of 6 come up a lot, square root of 2. Sometimes it's minus in between. Just depends on the problem. Okay, we'll see a minus one later today. But any questions on how we did that? So you got to write your number as a sum or difference, and then evaluate 4 different things. I think the hardest thing is just figuring out how do you write your number as a sum or difference. Like 15 is easy. It's 45 minus 30. Some of them are a little harder. Yeah.
Just scroll down. Thanks.
Okay, let's try, how about 75? How could you write the number 75 as a sum or difference of a number in each one of those lists? Yep.
45 plus 30.
Right, you could do a 45 plus 30. The thing is, we don't know the cosine sum formula yet. We will, and it's pretty much the same as that one. You just change one thing. What if I wanted you to write the number, let's say, how about 105? Does anyone see how you could get the number 105? Yep. I think if you write out a list like that, it makes it easier. If you're just trying to think in your head to do it, it's really hard. So then that's actually how I just made up the problem. I just picked a number in each list and subtracted them. All right? So, and there might be more than one way to do it as well. How about if I wanted 105, but I want to do it a different way? Does anyone see how you can get 105 as a sum instead of a difference? Yeah?
45 plus 60.
45 plus 60, yeah. So any problem that you can do as a sum, you can do as a difference. So when I show you stuff today, there's going to be lots of ways to do the same thing. So on a test, unless it tells you a certain way to do it, you could do it either way. Okay, let's try this one. So this is a verify. With verify, you always have 2 sides. And my hint last week was to always start with the side that's what? What'd you say, Jim? The most what? Yeah, the most stuff going on, yeah. Start with the side that's more looks complicated. Okay, it's always easier to take something that looks complicated and make it simpler. Don't take something that already looks simple and make it look more complicated. So we're going to start with the left. This is a cosine difference. Cosine difference identity. So we're going to use this again. You just have to identify the first thing and the second thing. Well, there's your first thing. There's your second thing. So not everything you're plugging in this time is a number. Okay, one of them is just a theta. Okay. So how does, we'll just put left-hand side. How does the cosine difference formula start? What's the first thing you write? Yeah?
Cosine of pi squared. Pi over 2.
Cosine of pi over 2, yeah. So, cosine of the first, cosine of the second. So cosine of the first times cosine of the second. Okay, so we've got cosine, cosine. What comes after that? Right before that. The addition, yeah. Addition. And now we do sine, sine. Sine of the first, sine of the second. Sine of the first. Any questions how I got that? Okay. So that's just the cosine difference, just plugging in what we have. Now, I have 4 things I need to figure out. Okay, so find out, well actually only 2. Cosine theta, you can't do anything with that. Sine theta, you can't do anything with that. Only 2 you can plug in are cosine pi over 2 and sine pi over 2. But if I want to use my calculator, what should I do first? Put it in radians. So put it in radians. Let's type in cosine pi over 2. Cosine pi over 2, and you get 0. Actually, I'm just going to write it above it. What's 0 times cosine theta? 0. So this part is gone. Okay, next part. Let's look at the sine of pi over 2. Sine of pi over 2. 1. What's 1 times sine? Sine. 1 times 1 would be 1. 1 times sine is just sine. 1 times sine gives me sine, and that's exactly what we're supposed to get. So it's kind of like a proof, but it's pretty easy because you just plug into the formula, and half of it always becomes 0. Okay, we're gonna try another one like that. Okay, let's try this one. Okay, which side is more complicated here? Yeah, the left, just like last time. And when I ask you what kind of identity is, I'm looking for you to tell me 2 things. It's a cosine difference identity. Name the trig function, name what's going on inside. Cosine difference. It's the only one I've taught you so far. So, Alec, how does the cosine difference start out again?
Take the cosine of the first part.
Cosine of the first.
Cosine of the second.
Cosine of the second. Yep.
And then you add to that the sine of the first times the sine of the second.
Sine of the first, sine of the second. Okay, how many things are there that I have to evaluate there?
2.
Just 2, right? Hopefully one comes out to 0, hopefully the other one comes out to -1, and then I'll be good. So if you got this far on the test, you'd get half credit, as long as you write this part down. Now the next part, just type it in and see what you get. Cosine of pi is -1. So you're going to have -1 times cosine. Plus, now we're going to type in, what am I going to type in next? Sine of pi, which is 0. And what's 0 times anything? 0, that's gone. So that part's gone. And what's -1 times cosine? Negative cosine. Let's scroll back up. That's exactly what we were supposed to get. Okay, so you're going to see 2 problems just like that on the test. Maybe there'll be a sum or a difference. I haven't taught you the sum yet. I'm going to show you that one right now. Okay. But any question on using the cosine difference identity? All right, let's look at the cosine sum identity. So I'm just going to write down what it is. You don't need to worry about the stuff above it. Let's just write it down. It's going to be cosine. You're going to have, if you have more room, just put it on the same line. Sine. And it's always first, second. So it looks almost the same. There's just going to be one thing different. What do you think is going to be different? It's going to be a subtraction. The difference formula used a plus. The sum formula is going to use a minus. That's the only thing that's different. Okay? Other than that, it's the same formula. In fact, you know what? Why don't I just try to put it on one line? There you go. So it's cosine minus sine. And that is the, if you want to label it, it's the cosine sum formula. We didn't really prove where it came from, that's fine. Just write down cosine sum formula. Cosine sum. And now, technically, if you forgot this formula, you'd be okay. Because anything that you can do as a sum, you can do the same problem as a difference somehow. So this formula kind of just gives you two ways to do the same thing. But you can do the same problem multiple ways. Okay, does everyone have the cosine sum formula? Okay. So let's do 75. And I know you can do 75 as a, could do it as a difference. But since we just learned the sum, let's try it as a sum. How can you write 75 as a sum of two numbers? And just to kind of remind you, they have to be numbers, one of them in each list. Yeah, 30 plus 45. You could also do 45 plus 30. It'll come out the same. What if you forgot the sum though? How could you write 75 as a difference? And you'll still get the same answer. You want to say it? Yeah?
120 minus 45.
Yep. If you forgot the sum formula and the directions didn't say you had to use it, you could do 120 minus 45 and get the same thing. But let's do it as a sum. So 30 plus 45. Okay, first thing I'm going to do is I'm going to write down the symbol. When I write it, does it use a plus or a minus?
What?
Cosine sum formula? Minus. So with the cosines, it's always the opposite. The sum formula uses a minus. The difference formula uses a plus. When we do the sine formulas, it's actually the same. So it's a little tricky to remember. But sum, when you write it, turns into a minus. What are going to be the two things I put on the left?
Cosines.
Yep, cosine of
45 and 30.
30. Cosine 45. All right, so we'll figure those out. What's going to come after the two plus signs? The minus sign.
The sine.
Yep, sine of
30
30
and 45.
and sine 45. Just figure out each one of those. Okay, let's start with cosine 30. If you switched into radians, we've got to go back to degrees. 0.866. How do we write that as a fraction?
Square root of 3 over 2.
Yep. 3 over 2. Cosine of 45, how do we write that one?
Square root of 2 over 2.
Sine of 30, we've done all these already. They're just in a different order. Sine of 30, that's just a half. And does anyone remember the sine of 45 from the last problem? Yep, square root of 2 over 2. Okay, so let's multiply the, you know what, let's do it all at once. What's the denominator going to be for everything?
4.
It's going to be a 4 with a minus in the top. What's going to be on the left side of the minus?
Square root of 6.
Yep, and on the right side?
Square root of 2.
And that's it. If you type that in, and you type in cosine of 75, you'll get exactly the same answer. But this is the exact answer. That's not a decimal. Okay, any questions on that? Okay, so the only two numbers that you need to know to do sines and cosines, you need to know root 3 over 2, it's 0.866, roughly, and 0.707 changes to root 2 over 2. What if it was negative 0.707? Well, this is 0.707 right here. So what if it was negative 0.707? You just put a negative in front of it, negative root 2 over 2. Right. So those are the only numbers you're going to see come up with sine and cosine. Right, let's look at the sine sum formula. So I told you that when we do the sine of a sum, the symbol here matches the symbol there. With cosine, they're opposites. That's one thing that's different. Here, they're the same. Plus uses plus. The other thing that's different is the sines and cosines. Before, the two cosines were together and the two sines were together. Now, it's one of each. Sine, cosine, cosine, sine. But it's still first, second, first, second. Okay, so that's the sine sum formula. So you could do a problem like the sine of 75. Just write it as sine of 30 plus 45 and then just go through it. Now, I said before that with cosine, anything you can do as a sum, you can do as a difference. So what about with sine? Do you think you really need the difference formula? No, you could technically figure out a way to do everything as a sum. Right? You say, well, how would you get 15 as a sum? Easy. 40 plus negative 35. So you technically could do 15 as a sum. You're just adding a negative. Okay? So you can get around not knowing the difference formula if you didn't know it. So there's the sign of a sum. What do you think the difference is going to be with the formula down below? It's going to be, yeah, go ahead.
I was going to say the same thing as that, except there's a minus sign.
Yeah. It's going to be the same thing, except there's a minus sign. And if somebody really wants me to do like the sine of 105, I can just make one up and do one. I don't think I had one. No. But if people want to see one, we can do one. All right, so let's just we'll pick one of them. Let's do the difference one. And let's do the sine of 75. Now, my first thought, when I see 75, I think of 30 plus 45. So when I see 75, I don't think to do it as a difference. But you can. And I think I asked about this one earlier. How can you write 75 as a difference of two numbers? And they have to be numbers from those lists.
120 minus 45.
You can do 120 minus 45. Probably not the way I would do it, but it works. And now we're doing the sine of a difference. Sine difference. Sine difference. Sine first, cosine of the second. So sine of the first, cosine second, minus cosine first, and then sine of the second. Cosine first, sine of the second. Okay, cosine of 45, sine of 45, those come up a lot. So hopefully we just kind of remember them after a while. But does anyone remember what we got for cosine 45 last time? Yep. Square root of 2 over 2. And how about sine 45? Yep. That's going to come up somewhere else. Not here, but it is going to come up soon. Anyone remember sine 45? Right, both the sine and the cosine of 45 are the same. Now let's check the sine of 120. All right, so sine 120. 0.866. So what's that one? That's your square root of 3 over 2. And cosine 120, negative 1/2. So just be careful because we're minusing a minus, so we'll see what happens. Square root of 3 times square root of 2 is square root of 6. Minus a minus turns into a positive. 1 times the square root of 2 is the square root of 2 over 4. So look at the answer for the sine of 75. Root 6 plus root 2 over 4. Now look at the answer to the first one we did. Cosine of 15. Root 6 plus root 2 over 4. They're the same. The cosine of 15 and the sine of 75 are the same answer. Any questions on the sine one? All right, and the tangent ones. Okay, the tangent ones, I don't usually remember the tangent ones. Okay, if I give you a problem with tangent, it's going to be a bonus question. So I'll probably give you one in the homework to try, but on the test it would be a bonus. And the reason I don't remember the tangent one is because even if somebody asked me to do a problem with tangent, I don't need to know that formula. It's a shortcut, but I can do it a long way without that formula. From last week, does anybody remember what tangent is the same as? It's just sine over cosine. So if you wanted me to find the tangent of 15, you can write it as 45 minus 30, but I don't know what the tangent difference formula is. But I do know that it's the same as this. So as long as I remember how to do the sine and the cosine, I can do the tangent without that formula. This is going to take a lot longer because I'm going to have to use two different formulas, one for the top, one for the bottom. But does everyone see how I can avoid this if I had to? I don't need it. That's why I never remember it. And then the tangent difference is the same thing except change all the signs. Plus becomes a minus, minus becomes a plus. Okay. And if you did have to do a lot of stuff with tangent, these formulas are much, much faster than trying to do it the way I'm telling you that I would do it. Okay, so out of those 6 formulas, the most important ones are the sine and the cosine. Those are the ones I would focus on. If you're not worried about a bonus question, then you don't have to worry about copying these down. Maybe you could do it without them, like I showed you. All right, so let's look at this. This is kind of like what I started off with at the beginning of class. I showed you something that you think might be true. It'd be nice if it worked, but it doesn't. We don't like to have numbers inside an argument to a trig function. We would rather it just have a 1. That's easier for what we're going to do tomorrow. We don't want 2s or 3s or anything else. Well, you can't just take the 2 and put it in front and say, okay, I'm good. It doesn't work. Even if you just think about it as like a transformation, what I just circled, that's a vertical stretch. When you have it on the inside, that's a horizontal stretch or compression. They're not even the same kind of transformation. So they're not the same. So what can we do then? Let's figure out, let's do example 4, but I'm going to do it a little differently. Let's want to expand the following. Sine 2x. That means I want to write it out. Like, expand it out. We know that you don't do it this way. You don't just stick a 2 in front. Now, if you think of 2x, how would you get 2x in an algebra problem? Like, what would have been the arithmetic that would have led up to that? Besides 2 times x. I know 2 times x is 2x, but what's another way to get 2x? Division? All right, so you could have like 2x squared divided by x. That would be 2x. But I'm thinking of something even simpler than that. Close. X times x would be x squared.
X plus X.
Yeah, it would be x plus x. That's how you would end up with a 2x. The simplest way. So think of it like that. X plus x. Now, look at the trig function. Look at the operation inside. What kind of identity did we just make right there? A sum of which trig function? Sine. That's the sine of a sum. So let's go back and use our sine sum identity and see what that comes out to. And that's the answer. Okay, so sine of a sum. Sine cosine plus cosine sine. Right. So let's write that down. Sine cosine plus cosine sine. And now it's first, second, but they're the same. The first one is x, the second one is x. Okay. So here, you have sine times cosine. Here, cosine times sine. That's kind of like having something like this. A times b plus b times a. What's the difference between a times b and b times a? Nothing. They're the same thing. So you could just think of it like this. If you really wanted. A times b plus a times b. So how many of these do you have? You have 2 of the a times b. That's what you get there. It's the same idea here. So Anyone think they can tell me what I would get when I combine that, just like I did right here? Yep.
2 sin x, cosine x.
Exactly. Yep. 2 sine x cosine x. That, let me get rid of these circles so it doesn't look as confusing. So what I circled is the final answer. That's how you take having a 2 inside next to the x and get rid of it. Now, from this point forward, I would just put this on your reference sheet, and I'm going to write it. Sine 2x equals 2 sine cosine. We don't have to go through figuring that out again. And that's called a double angle identity. Double because of the number 2. So sine 2, could be 2x, 2 theta, it doesn't matter. Whatever letter they use. 2 sine letter, cosine of the letter. The one for the cosine of a double angle. Now we could figure it out the same way we just did. We could write cosine of theta plus theta and go through it. But what ends up happening is that. And now that kind of looks like something we did before. We had a Pythagorean identity that kind of looked like that. It's not that, but it kind of looks like it. Does anybody remember the Pythagorean identity I'm thinking of? Something squared? Yes, sine squared plus cosine squared equals 1. That's not what we have there. We have cosine squared minus sine squared. It's a little different. It's kind of like it. Now, let's say, all right. If I wanted to take that identity that Jake just gave me, and instead of getting the 1 by itself, I want to get this by itself. How would you move sine squared to the other side? Subtract it. So does everyone agree that that is true? Cosine squared is 1 minus sine squared. It's just rearranging an identity we did a couple weeks ago. So watch what happens if I take, instead of putting this, instead of cosine squared, write 1 minus sine squared. That's 1 minus sine squared minus sine squared again. How many times did you just subtract sine squared? Twice. And that's another version of the identity. 1 minus 2 sine squared. And it's really just plugging in the Pythagorean one. And you can also plug in the Pythagorean identity the other way. Instead of for cosine, you could plug in for sine, and you get that. So with cosine, there's really 3 versions. I don't really think these two are that different, because it's really just the first one with something else plugged in. So this is the one that I always remember. And if I need a different one, I can figure it out with what Jake told me. Okay, so sine and cosine, again, by far, those are the important ones. I'm going to give you the tangent one. But again, if you asked me to do a tangent problem off the top of my head, I don't know that formula. I would think of it as sine over cosine. And those 2 formulas I do know. Right. So the only thing you'd see on a test with tangent would be like a bonus. And you'll probably see one in the homework. Okay, so any questions on these double angle identities? All right, so we're going to finish up with this one. What we're going to get into tomorrow is solving equations. If this was an equation, just don't write this, just watch this. And you wanted to solve that. Well, there's 2 problems with it. The first problem is that you're mixing trig functions. When you want to solve an equation, they all have to be the same trig function. Can't mix sines and cosines together. It's like mixing x's and y's in the same equation. Can't do it. But even if these were all the same trig function, let's just pretend that I erased this and made it sine. Let's say that was the problem. There's still something else that's wrong, and it's that. You can't have a number in front of x when you're trying to solve an equation. It has to just be like this. I mean, technically, there is a number in front of that. What number is in front of x there?
1.
A 1. That's what it has to be when you want to solve an equation. It can't be a 2. So all we're going to do today is practice rewriting this so the 2 isn't there. Okay. How about this? Is there any number in front of the x there besides a 1? Jade? No, that one's fine. You can have a 2 way in front. You just can't have a 2 next to the x, or a 3, or anything else. So this is the one we have to fix. What can we change sine 2x to? It's a little bigger, but there won't be a 2 in front of the x anymore. So I like the sine, that's good.
Sin x and
Cosine x. Okay. So now we've rewritten it. So every number in front of the x is a 1. That's good. What do both of these have in common? Here and here. They have a 2 and what else? Cosine x. When you have two terms that have the same thing in common, what can you do? Begins with an, it's like the opposite of distributive property. Begins with an F. Well, FOIL is distributive property, so the opposite factor. We're going to factor out 2 cosine x. Okay. I'm doing that, not that they said to do it here, but you're going to have to do it tomorrow, so I'm just showing you how it works. Technically, at this point, you've done what they wanted. But to write it just a little bit nicer, if you factor out 2 cosine x, what would you have to put right there? So when you distribute, you get back what you started with. 1. Yep. 2 cosine x times 1 is 2 cosine x. And what would you put right here? So when you do 2 cosine x times what you tell me, you get what's underlined. Sine. Yep, sine x. Because 2 cosine x times sine x is 2 cosine x sine x. So that's the final answer in a factored format. That's also the final answer above it, not factored. They're both correct. But the bottom one you need to know for tomorrow. Any question on that one? Okay, so we took a look at the sum and difference identities, sine and cosine, most important ones, and the double angle identities. Again, sine and cosine are the most important ones there too. There will be a bonus on the test. Might have something to do with the tangent ones that I told you today. It might have something to do with what we're going to do later in the week. But there will be a bonus. All right, so homework. The only continuous range is 2 through 5. And then the rest are just single problems. So 9, 10, 17, 18, 29. 31, I think, has multiple parts. Just do part A. And then 37 and 41. Okay, so we'll look at that tomorrow. And then tomorrow we will finish Chapter 7.